Hello guys, welcome to my fourth class of vector space. First try to consider definition of linear span. Even though it's not included in your open elective syllabus, without span you can't understanding basis. Therefore, first try to take care for linear span. What's the definition of linear span? Let S be a non-empty subset of a vector space over a field F, and also having S some set of vectors A. I taken a vector S is having 1 to alpha 1 to alpha n. Then the set of all linear combinations of finite number of elements of S is called a linear span of S and is denoted by L of S. That is, L of S is nothing but A1, instead of C1 I taken A1, that's all. A1 alpha 1 plus etc. A n alpha n such that A star belongs to where actually F, and then alpha I star alpha 1 to alpha n belongs to S for I is equal to 1 to n. Mean, observe carefully, one we have to consider one of the non-empty subset of a vector space or a field F, the set of all, then the set of all linear combinations of finite number of elements of S is called a linear span of S and is denoted by L of S. Now for example, I written here, suppose I choose one of the vector belongs to L of S, S having n vectors. S is having how many vectors? N vectors. S having n vectors, suppose L belongs to span. L of, we have to write the S is in a square bracket, means that denotes span. L of S means span of S. Linear span of S means L can be written as linear combination of vectors of S. What are the vectors you have in S here? What are the vectors you have in S? Only n vectors. Therefore, L alpha can be written as C1 alpha 1 plus C2 alpha 2 plus etc. Cn alpha n, where alpha I star belongs to S, Ci belongs to F. Please try to understand linear combination means non-empty set vector, they having some set of vectors. Say here I consider as having n vectors. Suppose choose any vector in the span of S means that vector can be written as or linear combination vectors of that span. Otherwise, the alpha does not belongs to L of S. Okay, let us move to the problem here. This is one of the problem here. I'm going to consider two problems here. First problem is let S must be equal to, what is my S? S having three vectors. With components is what actually? Three components. Means this is a three-dimensional vector space. 1 minus 3 comma 2, 2, 4, 1, 1, 1. Be a subset of vector space over a set of real numbers with dimension. What is the dimension here? Dimension is 3. Show that the vector 3 comma minus 7 6 belongs to L of S. Means this vector span yes. It is enough to show that this 3 minus 7 6 can be written as linear combination of vectors of S. Then we say that this vector belongs to L of S. Means this vector span by S. L of S means span of S. Linear span of S. Now here what we are going to consider here for my convenient, I choose alpha 1 is equal to 1 first vector, alpha 2 is a second vector of S, alpha 3 is nothing but third vector of given problem of S. We have to show that 3 comma minus 7 comma 6 belongs to L of S. Means it is enough to show that that vector, what's a vector? 3 comma minus 7 6 can be expressed as a linear combination of vectors of alpha 1, alpha 2, alpha 3. Just now we know that what's the meaning of linear combination. Same thing. Now to consider this vector can be written as, now assume that this vector can be possible to write linear combination of alpha 1, alpha 2, alpha 3, but I don't know what are the scalar. Therefore I taken unknown C1, C2, C3. Substitute alpha 1, alpha 2, alpha 3 and simplify that. Then you know how to simplify. You take C1, C2, C3 and then add the first component, add the second component, add the third component. And two vectors are equal means corresponding components are equal. We get a system of equation with three equations with three unknowns. Write the augmented matrix, because in the previous problem we get very easily C1, C2, C3, but here you don't get it. All three equation, all C1, C2, C3 must be present. What we are going to do, easiest way is write in the form of augmented matrix. You know how to write the augment matrix for this from the system of equation. You write the augment matrix, take the quotient of C1, C2, C3 and constant in each of the equation. You already studied in first chapter. From the augmented matrix, using elementary row operation, try to convert this augmented matrix must be in the echelon form. I don't want row reduced echelon form, just echelon form, just like a Gauss elimination method. You already studied in first year. Now you convert this by using elementary row operation. I am not going to explain how we have to apply elementary row operation, because everyone you know in the first chapter how to apply elementary row operation, and also I explain once again in the revision class for the first module how to apply the elementary row operation. Now first row, first element must be non-zero. Keep that row as a fixed. Convert the rest of the element occur in the first column, second row, third row, first element must be 0 by using elementary row operation. Elementary row operation either may be interchange two rows, either may be multiply any row with some non-zero scalar, and then either maybe I have to add with any one row with other row. These three operations I follow, these operations are called elementary row operations. Yeah, I fixed the first row. I to convert these two by using elementary row operation. What I did, I took this is 0 means right to multiply it by 3. Therefore, R2 plus what I did here, 3 what about that R2 plus 3 R1. We get this. And then I have to convert this is 0 means I have to multiply it by minus 2 R3 plus minus of R2. After that, observe second row, second element must be non-zero. This is my pivotal element. Using this pivotal element, I have to convert the following row of third row, second element must be 0 by using elementary row operation. What we are going to do, you fix this row and then I have to convert this is 0 means multiplied R2 by 3 by 10 and then we get finally. After that, for my convenient, what I did, this is common in the second row is reduced to echelon form, fine, but is commonly have 2, therefore divided by multiplied, not multiplied, here multiplied by 5, but here I to multiplied by 1 by 2, means I to divide by 2 means multiplied by 1 by 2. We get 5 to 1, 0, 1. Then you write the what about system of equation. We get simple system of equation. We get a simple what actually system of equation. You know how to write the system of equation from this. C1 plus 2C2 plus C3 equal to 3. C2, 5C2 plus 2C3 must be equal to 1 and then C3 is equal to 3. Then you, from C3 we get 3 value. Substitute in the second equation we get C2 value. Substitute C3 and C2 in the first equation we get C1 value. I written everything in this paper. Then finally we get C1, C2, C3 value. Then we get a value, therefore we say that 3 comma minus 7, 6 can be expressed as a linear combination of vectors of given alpha 1, alpha 2, alpha 3 with scalars. What's a scalar here? C1 is 2, C2 is minus 1, C3 is 3. Therefore, then we say that this vector, the given vector 3 comma minus 7 6 is belongs to L of S. Is spanned by S. See, keep in mind span means I have to choose any vector that can be written as linear combination of vectors of S. Then we say that is spanned by S. I think it's clear. Moving to the another one different problem. The problem is here show that, yeah, in this problem what we are going to do, show that the vector 2 minus 5 3 belongs to V3 of R. This means set of all V is a vector space over a set of real numbers with dimension 3. Means I choose any vector in V3 of R. The components of that vector is 3. Is not in L of S, where S is having 3 vectors with how many components? 3 components, because S is a subset of V3 of R. S is also having a dimension is 3. Is not in L of S means this given vector 2 comma minus 5 comma 3 cannot be expressed in the linear combination of vectors of S. That's why in the solution what I written, it is enough to show that 2 comma minus 5 3 cannot be expressed as a linear combination of vectors of S. Okay, therefore consider, just imagine this given vector 2 comma minus 5 comma 3 can maybe is possible to write it in the linear combination of one combination of vectors of S along with the unknown scalar C1, C2, C3. Try to find out C1, C2, C3 here. What we did in the previous problem like that, multiplied by C1, C2 and then add the first component for these, add the second component, third component. Two vectors are equal means what? Corresponding, what about that? Corresponding components are equal. Once we equate that, we get a system of equation with the three unknowns way of three equations. Write the augmented matrix. You know how to write the augmented matrix. Once you write the augmented matrix, you convert this augmented matrix in the which form? Echelon form. Now already explained in the previous problem how to convert echelon form. Not necessary to explain once again how to convert echelon form. After you convert echelon form, what we did? We rewrite the equation. First equation, second equation, third equation. While writing third equation, there is no meaning. 0 is not equal to 3 by 2. This shows that the system is inconsistent. System is inconsistent means we already know that in the first module system of linear equation, once a system is inconsistent, there is no solution. There is no solution means we can't find out the values of C1, C2, C3. We can't find out the values of C1, C2, C3 means the given vector 2 comma minus 5 3 cannot be expressed in terms of the vectors of S. Therefore, this vector does not belongs to L of S means this vector does not span by S. This is a way to prove L of S. End of this class, you please try to understand any vector is spanned by S. Here I taken S or W means that vector can be written as linear combination of vectors of the corresponding set. Suppose L of S means is a span of S. Alpha belongs to L of S means that vector can be written can be expressed in the linear combination of vectors of S. Then only say that alpha is a span by S. Otherwise alpha is not span by S. That's why I consider totally two problem based on span, because in further classes we are going to discuss linearly independent, linearly dependent, basis, dimension. Based on the basis they are going to ask the problem. Now once you verify basis, the span is very important. Span is one of the condition in the basis. Therefore without knowing span, this is a chain continuity. That is not mentioned span in the syllabus, I have to know, because in the basis one of the if we want to verify whether it's a basis or not, one of the condition is first you have to verify whether it's a span or not. That's why I taken much important to explain that. Thank you very much for listening my revision class of vector space. I'll come and meet you in the next class. I'm going to explain linearly dependent, linear independent basis. Based on that, I'm going to take one problem. I'm requesting everyone, you please go through the rest of the problem from my notes. This is not a regular class. This is on request for the students. I'm doing a revision class. I'm sorry to say that I don't have a whiteboard. I don't have a person to do video. I'm doing my personal own both explanation and video. You please try to understand my situation, because everywhere is lockdown. You please adjust what about facilities in my house. Based on that I'm doing that. Thank you very much for listening for the. If you have any doubt based on that also, in any you are not understanding any concept, you feel free, you put a what about message in WhatsApp group LALA20 or in my video comments also. Thank you very much. I'll come and meet you shortly in next class. Thank you.